Good afternoon, students. Today is October 2, 2025, and we will try to know what are the topics that you're going to learn in the first chapter of NCERT textbook for CBSE board. Chapter number 1, solution carrying 7 marks. So the solution is what everybody knows. The solution is a mixture of two or more than two components, right? Two or two, so we say substances, and they may mix in such a way that they are heterogeneous or homogeneous. But here we're learning only about homogeneous solution, in which the components are perfectly mixed everywhere. The concentration of the substances or the components are same, and that is called a homogeneous solution. And there may be more than two components in the solution, but we'll stick our learning to only binary solutions where only two components are present. So based on the physical state of those components, one which is based on the quantity of the physical state, there may be the component which is present in the larger amount. So for example, if you put salt into water or a glass of water, water is present in large amount. So water is a solvent, and the salt that you're putting, the table salt that you eat every day, you put in it and you stir it, then that becomes a solution, right? Then the pinch of salt that you are putting, that is called solid, because it is present in lesser quantity, and the one which is present in larger quantity, it is not solvent. So solute, solvent, they combine together forms a solution. Based on the physical state of the solute and solvent, based on the physical state of the solvent, the larger quantity, there may be three types of solution: gaseous solutions where the solvent is gas, or liquid solution where the solvent is liquid. Similarly, a solid solution where the solvent itself is a solid. For example, if while making jewelry, the liquid copper is dropped and mixed together. That is sometimes called alloy. Alloy is also a kind of solution. Remember that solution doesn't mean that it will always be liquid. The larger component will be liquid. It may happen that the larger component, the solvent, is a solid, right? For example, that in jewelry where copper in small quantity is mixed to the gold, and that too is very homogeneous because you are mixing them not as a hard solid, but as a liquid. You melt them and you mix them. So that is called solution. Now, okay, remember then there are many ways of expressing the concentration of the solid, how much solid is dissolved in the solution. The way of expressing the concentration of the solid or a solvent, there are many ways. There are 7 ways of expressing that concentration. Maybe mass percentage, we call weight by weight; volume percentage in the liquor that we drink, V by V, volume by volume; mass by volume, where the solid's weight is given, then the solution weight of the solution is in terms of volume. Then when the quantity of the solid present is very traces amount, for example, well, in the air, the presence of dust particle in the air, it may be in very traces amount, that is expressed in parts per million. Then mole fraction is a very important one. Mole fraction, the component A, is expressed in terms of the number of moles of the solid and the solvent. Now the term mole is coming up. Suppose the solution contains two components, A and B. The mole fraction of component A will be number of moles of component A divided by total number of moles of the solid and solvent, component A and component B. That fraction will be mole fraction. Mole fraction will not have any unit because this will mole, this will mole. The unit will cancel each other. So it is a unitless way of expressing. Then molarity, number of moles of solid present in 1 liter of solution. Molality, number of weight of the solvent present in 1 kg of the solvent. So this is in terms of, all other things are in terms of solution, right? But this one, molality, it's in the terms of solvent. The weight of the solid present in 1 kg of solvent. That's called molality. It's denoted by small m. Molarity is denoted by capital M. I'm not going into details. I've just wanted to give an outline of what are the things that you are going to study in the solution. And then vapor pressure of then solubility, how much solid particle can solid solid can be dissolved, this solution we call in a liquid. The term this solution, then what is saturated solution, what is unsaturated solution, what is the effect of the temperature on the solubility, whether it increases or decreases. Then Lee-Chatter's principle has something to say about the effect of temperature on whether it will increase the solubility or decrease the solubility. It depends on the something called the change in enthalpy that you have learned in class 11 in thermodynamics. Then what is the effect of pressure on the solubility? What is the effect of temperature on the solubility? Then there comes Henry's law, which says the partial pressure of one of the component is proportional to the mole fraction of that component in that solution. And this is Henry's constant. It's proportional. So when proportional sign is replaced by an equality, then you need to insert one constant. Here it is called the Henry's constant. Then what is vapor pressure of liquid? When suppose both the components in the solution are liquid, you're mixing two liquids, then the liquid will also some part of the liquid will change to vapor, and that vapor will act as a pressure, and that pressure is called vapor pressure. So what do you mean by vapor pressure of the liquid? And what is Rawls law total if there are two liquids, say P1 and 2, and they have a partial pressure, their vapor pressure is P1 and P2, and total pressure of the two component is given by P1 P1 naught plus P2 difference in the partial pressures of the two component than the mole fraction of the second component. So it gives a relationship. Why is Rawls law important? It gives a relationship between the total pressure of the gas and the mole fraction of one of the component. That's why that is the significance of Rawls law. Those liquid solutions which follows the Rawls law in all temperatures and at all ranges of temperature, that is called ideal solution. And those which do not follow, they are called non-ideal solutions. I mean, if this equation holds true, and that is called an ideal solution. If the Rawls law doesn't hold good in that solution, that is called non-ideal solution. Most of the solutions are not perfectly ideal. And then comes colligative property, which is the property of the solution, which depends on the number of particles or number of moles of the solid that you are dissolving. These properties are not dependent on the kind of the solid that you're adding. It just depends on those property of the solution. It depends of the solvent or of the solution. It depends on the quantity of the solid that they are putting in, or the number of solid, the mole fraction or number of moles solid that they are putting in. Those properties are called colligative properties, and that is relative lowering of vapor pressure of the solvent, then elevation of boiling point of the solvent, then depression of freezing point of the solvent, and osmotic pressure of the solution. See, the first three properties are the properties of the solvent, and the last property, that is osmotic pressure, is the property of the whole solution. So these are colligative properties. There are mathematical relationship through which we can find out the molar mass of the one that you are dissolving solid or the solvent, that we will learn detail in our next class. So these are the things that you're going to learn in the chapter solution. We'll go details into it. Please stay tuned to me.